Integration by substitution. Hit pause, copy the lesson objective down. Once you've done that, we're going to move straight into an example. So here's our example. We've got to integrate x times the square root of 2x plus 5 with respect to x. And they've given us a substitution to use. So first things first, let's have a quick look at this, this integral. We need to integrate x times the square root of 2x plus 5 respect to x. Let's put brackets around it. Well, this is in three parts really. We can identify this as a three-part differential for the purposes of substitution. We've got our x here, then we've got this 2x plus 5, which is also our substitution, and then we've got the differential with respect to x. What we're going to try and do is integrate with respect to u. So these three terms are going to change. In order to do that, we take our u here. We've got u, which is equal to 2x plus 5. Now that implies then that x, if we rearrange and make x the subject, x is going to be equal to u minus 5 divided by 2. So that's the 2x plus 5 changed to u. The x becomes u minus 5 over 2. But we've still got this dx here, which we've got to change to du. Now if I differentiate u with respect to x, du over dx, I get 2. Rearranging that, du is equal to 2 dx, which means that dx is equal to a half of du. Now I can substitute these three terms. Let me put a blue box around them. I can substitute for u, 2x plus 5, substitute for x, u minus 5 over 2, and now I can substitute for dx as well. So let's do that in the equation. So let's go red again. So we can say that the integral of x times the square root of 2x plus 5 with respect to x is equal to, instead of x, I've got u minus 5 over 2 times the square root of u, and instead of dx, I've got half of du. Okay, so let me simplify this before I integrate. I've got 2 times 2, so I can take the quarter out. And I've got the integral then of u minus 5 times u to the power of a half with respect to u, which is great. If we expand, we can expand, simplify, and then integrate. So we've got a quarter of the integral of u to the power of 3 over 2 minus 5 u to the power of a half with respect to u, which is equal to a quarter. And if I integrate, I've got add 1 and divide by the power, so that's going to be u to the power of 5 over 2 all over 5 over 2 minus 5 u to the power of 3 over 2 over 3 over 2. Let's close the brackets there because the quarter affects that, and don't forget your constant. Simplifying, that gives us a quarter of 2/5 of u to the power of 5 over 2 minus 10 over 3 u to the power of 3 over 2 plus our constant. Well, before I sub back for u to finish off, I'm just going to put that quarter back in. So that's going to be 2 over 20 which is 1 over 10, u to the power of 5 over 2. So my writing's getting a bit smaller because I'm running out of room. Minus 10 over 12, 5 over 6, u to the power of 3 over 2, plus c. And now I can sub back for u to finish off. That's going to be equal to a tenth of u is 2x plus 5 to the power of 5 over 2 minus 5 over 6 of u, which is 2x plus 5 to the power of 3 over 2 plus the constant. Okay, so we've integrated quite a complex integral with the substitution, and we substituted for 3 parts. We substituted for u, then and for x and dx. So hit pause, copy that example down. Once you've done that, hit play, and we'll move on. Okay, so this is our second example, and you'll notice that it's the same integral, the integral of x times the square root of 2x plus 5 with respect to x. Exact same integral, but this time the substitution has changed. Now you will be given the substitution in an exam unless it's obvious. So you're usually given the substitution. So let's have a look at this substitution here. U squared equals 2x plus 5. So if I want to differentiate that in situ, implicit differentiation, I get 2u du by dx is equal to 2. Simplifying, that gives me 2u du, which is equal to 2 times dx, and the 2's cancel, so dx is equal to u du. So u squared equals 2x plus 5. That implies that x is equal to u squared minus 5 divided by 2. Okay, so we've got our 3 substitutions. I've got my 2x plus 5, I've got my x, and I've got my dx. So let's substitute and then integrate. So we've got the integral of x times the square root of 2x plus 5 with respect to x. And that's equal to the integral of x, u squared minus 5 over 2 times the square root of u squared, and dx is u du. So if I simplify, expand and simplify, I've got the integral. I'll take the half out, makes it easier for now. U squared minus 5, square root of u squared is u, times another u, so that's u squared du. So we've got a half integral of u to the power of 4 minus 5 u squared respect to u. So integrating, we've got add 1, divide by the power, u to the power of 5 over 5 minus 5 over 3 u cubed plus the constant term, don't forget that. So we've got u to the power of 5 over 10 minus 5 over 6 u cubed plus the constant term. We can sub for u, which is the square root of 2x plus 5. So that gives us, this is going to be equal to 2x plus 5 square root of to the power of a half, so 5 over 2. Let's make that a tenth instead of over 10, minus 5/6 of 2x plus 5 to the power of 3 over 2 plus our constant 10. So exactly the same answer, different substitution, but the same result. Okay, so hit pause, copy the example down. Once you've done that, hit play and we'll look at another example. Okay, in this example, we're going to use the substitution u equals sine x plus 1 to find the integral of cos x sine x, brackets 1 plus sine x to the power of 3 with respect to x. Now this example shows that sometimes we can use what's already in the integral to help us when we change the dx to du, but you'll see that as we work through it. So let's have a look at our substitution. We're told that u is equal to sine x plus 1, which means that sine x is going to be equal to u minus 1, and when we differentiate with respect to x, we've got cos x, which means that du is equal to cos x dx. Now if I rearrange that, I can take my cos x, put it next to the dx there, and that should work for me. So let's try that. I've got the integral then of cos x sine x, 1 plus sine x cubed with respect to x. So we can substitute. Let's do that. I tell you what, before we substitute, let's rearrange. So that's the same thing as the integral of sine x times 1 plus sine x cubed, and I'll just put a cos x here, cos x dx, which is the same thing as du, if you remember. So now I can substitute. Sine x is u minus 1. 1 plus sine x is u, so that's u cubed. And cos x dx is du. So we've used our integral by rearranging it to simplify cos x dx to du. Right, so expand and simplify. Integral of u cubed, u to the power of 4 minus u cubed with respect to u. Integrating that leaves me with u to the power of 5 over 5 minus u to the power of 4 over 4 plus our constant term. And I can sub back for u. So that's sine x plus 1 over 5 to the power of 5 minus sine x plus 1 to the power of 4 over 4 plus c. Okay. I think that's quite useful. It's useful to spot, if you can, sometimes. I'm going to say this, but back in the day when we weren't given a substitution, many of hours of practice would lead you to spot what you could use in your workings. So that's important in this case, to recognize that from this equation we've got here to integrate, by rearranging, we can put a cos x next to dx, and so we got du. Okay, hit pause, copy the example down. Once you've done that, hit play, and I've got one more example for you. Okay, so with this example, we've got to prove that the integral of 1 over the square root of 1 minus x squared is equal to arc sine x. So we're not given the substitution, But with practice and your exquisite and great knowledge of trig identities, you'll be able to, with practice, spot that the substitution should be, we let x be equal to sine of theta. So if we differentiate x with respect to theta, dx over d theta, we get cos of theta. So we can say that dx is equal to cos theta d theta. Okay, so let's make that substitution in our integral then. So we want to integrate, I'll tell you what, let's write consider LHS, left hand side, 1 over the square root of 1 minus x squared with respect to x. That's equal to the integral of, making our substitutions now, 1 over the square root of 1 minus x equal to sine theta, so sine squared theta, and dx is equal to cos theta d theta. Hopefully you're now seeing why we've left the cos theta there. That's because when we look at this square root of 1 minus sine squared theta, it's 1 over the square root of 1 minus sine squared theta is equal to cos squared theta, because we know cos squared theta plus sine squared theta is equal to 1. So that's going to be the square root of cos squared theta times cos theta d theta, which is equal to the integral of cos theta d theta, square root of cos theta is cos theta. So that's just the integral of d theta, which is equal to theta plus our constant. So we've done our integration, now we just need to sub for theta. Now we've got x equals sine theta, which means that theta is the inverse or the arcsine of x. So we can sub for that. So that's going to be equal to arcsine x plus c, which is the right hand side. Job done. Hit pause, copy that example down. Once you've done that, I've got one more example for you. Okay, so let's have a look at this this integral. This time it's a definite integral, so we're integrating within the limits from 0 to 2. So it's a slight change there. This time I'm sure you can guess what the substitution is going to be. Let u be equal to x plus 1. Okay, that means that x is equal to u minus 1, and when we differentiate u with respect to x, we get 1, which means that du equals dx. That's nice and straightforward. One thing we have to consider though are these limits. Now these are limits when we're integrating with respect to x. All our terms are in x. When they're u, these are going to change because u equals x plus 1. U is equal to x plus 1. That means that if x is equal to 0, that means that u is going to be equal to 0 plus 1 or 1. And if x is equal to 2, u is going to be equal to 2 plus 1, which is 3. So our limits, when we integrate with respect to u, go from 1 to 3. Right, let's write our integral out and substitute. So we've got x times x plus 1 cubed with respect to x is equal to the integral of x is equal to u minus 1, x plus 1, which is u, cubed, and dx is equal to du. From now it's changed. Oop, that was a 0 there, to 2, to 1, to 3. Okay, let's expand. So integral from 1 to 3 of u to the power of 4 minus u cubed with respect to u. And so we can integrate. So add 1 and divide. So u to the power of 5 over 5 minus u to the power of, add 1 and divide, 4 over 4. We don't need our constant this time because it would just subtract itself. And so we've got 3 to the power of 5 over 5, that's 5, minus 3 to the power of 4 divided by 4, minus a fifth, take away a quarter. Working it out, should get 48.4 minus 20. Which is equal to 28.4. Okay. Hit pause. Copy that example down. Because it's our only definite integral example, let's have a look at one more quickly. Okay, so here's our last example. We've got to integrate from 0 to pi by 2 cos of x times the square root of 1 plus sine x with respect to x. Okay, so we're going to let u be equal to 1 plus sine x. Okay, now I don't need x to equal anything, so I'll leave it as that. When I differentiate u with respect to x, I get cos x, which means that du is equal to cos x dx, which means if I rearrange that, cos x and dx, and I've got u equals 1 plus sine x, that'll work. Now I've got to just have a look at my limits. Now when x is equal to 0, let's do pi by 2 first. When x equals pi by 2, that means that u is going to be equal to 1 plus sine of pi by 2. And we know from our graph, our sine graph, pi by 2 is 1. So sorry, sine of pi by 2. Sine of pi by 2 is 1, so 1 plus 1, u is equal to 2. And when x is equal to 0, u is equal to 1 plus sine of 0. Sine of 0 from our graph is 0, so u is equal to 1. Right, let's sub into our integral. It goes from 0 to pi by 2, cos of x square root of 1 plus sine x with respect to x. Rewriting this, moving the cos x next to the dx, just moving it, so nothing's changed really. No material change. Pi by 2. You've got the square root of 1 plus sine of x times cos x dx. So now we can sub. It's equal to, the limits have changed, goes from 1 to 2. Square root of 1 plus sine x, so it's the square root of u, or u to the power of a half. Cos x dx is equal to du. Marvelous. So now I can integrate. Add 1 to the power, so it's going to be u to the power of 3 over 2 divided by 3 over 2 from 1 to 2, which is equal to 2/3 of u to the power of 3 over 2 from 1 to 2. which is equal to, subbing in, that'll give me 2 over 3 times 2 to the power of 3 over 2. Square root of 2 cubed, that's 2 root 2, isn't it? Minus 2/3 of 1, which is just 2/3. Working it out, so that should give me, 2 over 3 times 2 root 2 minus 2 over 3. That's job done. I can take the 2 over 3 out if I want to, just to simplify. And you got 2 root 2 minus 1. Job done. And that was our final final example. Okay, I think they're easier when you have limits, and they need to be, otherwise they'd be too long. Hit pause, copy the example down, and I've got a couple of questions for you to have a go at. Right, so we'll be looking at exercise 11E. It's brand new method, so I think you want to practice as many as you can. Okay, we've only got 9 questions. I'd say do the majority of 1 and 2, and you'll be on your way. And once you've done that, then you're into the swing of it. Okay, good. Good luck.